Given the function, we've got this function here that's a generic quadratic. Find a, b, and c if f of 0 equals 2, f of 4 equals 0, and f of 5 equals 0. Well, we can see here that we've got f of 0. So when x is 0, the y value is going to be equal to 2. So that's a y-intercept there. These two, when x is 4, y equals 0, and when x is 5, y equals 0, means that these are going to be x-intercepts. That's handy for us to know. Now, I would actually go about doing this the non-suckers way, if it was me. So what the textbook and what a generic sort of set of values, well, the generic principle for this, is we can set up simultaneous equations. That's one way of going about it. So what the idea is, you would substitute, you would say, all right, if x equals 4, y equals 0, and we know that c is the y-intercept, and it's going to be equal to 2. So we can actually just do a whole lot of substituting here. A 4 squared plus b times 4 plus 2 equals 0. And you would get 16a plus 4b plus 2 equals 0. And that would be one equation. And then we can set up another equation with the other setup here, which would be f of 5 equals 0. So x equals 5, y equals 0. So a 5 squared plus b times 5 plus 2 equals 0. 25a plus 5b plus 2 equals 0. So we can set up these two equations, but that's a very laborious task. We can also do it on the calculator as well. If these are intercepts, why not do factorized form? It's half our work done for us. So factorized form, if you remember, looks something like y equals a, x plus b, x plus c. So what I'm going to do, and in fact I'll get rid of the b and the c here because that could be confusing. Let's just do k and j. What that means is that I have got intercepts and I just need to know what the dilation factor, what that a at the front doing, is telling me how much that parabola has stretched. So really what we've already figured out this, because those are positive x-intercepts, so that means there's one at 4 and there's one at 5. I just need to do one substitution, so I'm going to sub x equals 0, y equals 2 to solve for a. And so that's going to be 2 equals a, brackets 0 minus 4, 0 minus 5. So 2 is equal to 20a. A is equal to 1/10. Because 2 divided by 20 is 2/20, which would be 1/10. So then all I need to do there is just expand that brackets because we want to find a, b, and c. So we'll have y is equal to 1/10 x minus 4, x minus 5. So this is going to be x squared minus 5x minus 4x plus 20. So x squared on 10 minus, let's actually simplify that, shall we? We've got negative 5x minus 4x, which would make that negative 9x. So that'll be 9 on 10x plus 2. So a is equal to 1/10, b is equal to negative 9/10, and c is equal to 2. Now you could go and get the exact same answers on the for simultaneous equations. If you are unsure how to do that, well, here we go. Let's do this. Now, if you've gone and defined something, may I suggest getting used to going to Action, Command, and Clear A to Z, because that will clear anything that you have defined. So what I'm going to do is I'm going to go and define f of x is equal to a times x squared plus b times x plus c. And what I'm going to do is I'm going to go and use this button here. So in case you didn't see that, under Math 1, there's like a little sort of brace or curly bracket or mustache bracket that has a little rectangle in there. And what I'm going to do is I'm going to go and simply write the instructions as seen here. F of 0 equals 2. F of 4 equals 0. F of 5 equals 0. A, B, C. Bang. It's done that for you. You'll notice there I've got it in decimals. Let's go and get that as a fraction, and there it's all done for us. For this problem, you can do this by hand. I'm going to just do it very quickly on the CAS calculator here. Consider the graphs g of x equals x squared minus 4, j of x is equal to x plus 10. First of all, find out when g of x is equal to j of x, and then find out what values of x is, what values of x will give you such that the g of x is greater than j of x. So let's get calm our farms and let's do this. So if I go to the main, and again what I'm going to do is I'm going to go Command clear A to Z, and I'm going to clear all of this business. Now this first one is just asking when do those two equations meet. Well, that's easy. We can just go and you would just make the two equations equal each other and solve for x accordingly, substitute that in to find the y values, but ain't nobody got time for that, so we're going to go and do this entirely on the calculator. Define j of x equals to x plus 10, and then what we'll do is we're going to solve, and we're going to do g of x equals j of x. So that gives us these very horrible, complicated x values here, which is a little bit annoying. So what we can then do is substitute accordingly. So what we're going to do is we're going to go and write g of this horrible looking thing. And what we'll do is we'll simplify that answer. That will get us the y values there. So this is our coordinates. Actually, I just realized that we don't even need to find coordinates. We just need to find the x values. So the x values, we've solved that. X is equal to 1/2. We may as well just write it as I sees them. So that's the points where those two, the x values such that g of x equals j of x. So those are my two x values. If that had been a different question, which is find the coordinates, then I would need to substitute like I've done there. Now it's asking for when g of x is greater than j of x. Now here I would highly recommend showing this as a graph. So I'm going to go to graph and table. I'm going to put g of x and I'm going to put j of x on a graph. There they are. So we want to see the points where g of x is greater than j of x. So what we're going to do is just zoom out a smidge here. So what it's asking is what x values will give me will result in that part of the graph and that part of the two graphs, because that's the points where the g of x is greater than or higher than the red line, which is j of x. So I already know, according to this, that these two values here, the negatives root 57 over 2 plus a half and root 57 over 2 plus a half, that's these points. That's the answers to A. So the answers to A are these 2 points here. So that's our answers to A. So in other words, all I need to do here is just to say, well, x, now I could write this as interval form. So x is such that x is an element of all real numbers except, now I can write this in several ways. I'm going to write it in a few ways just so you know how you can write it. It's an element of all real numbers except this interval. So we want greater than, so it's going to be except the interval negative root 57 over 2 plus a half, root 57 over 2 plus a half, and that's a close bracket, because it's greater than. Or I could write it as simply negative infinity to negative 57 root plus over 2 plus a half. Union, round brackets, union root 57 over 2 plus a half to positive infinity.